So, welcome to the another video lecture on digital principle and computer organization. So, in this video, we are going to discuss about cache memory. So, before going to discuss about the cache memory, we have to know what is meant by principle of locality or locality of reference. It explains why the cache memory works efficiently. Generally, the advantage of cache memory is um, it works fast. It makes the CPU to work fast. So, the principle of locality states that the program tends to access a relatively small portion of memory repeatedly for a shorter period of time. It may be of mainly of two types. Here we are going to see about three types because this temporal and spatial are the main types, and sequential locality is a subset of the spatial locality. So first, let us discuss about what is meant by temporal locality. Let us discuss one example. Here, x is equal to x plus 1 and y is equal to x plus 2. So here you can see the x data of the x is recently used, right? So I can take x as data or x as instruction. Therefore, this instruction or data must be placed inside my cache. So this is an example for the temporal memory. Next, one is spatial memory. It represents space. So here the memory location which is nearly accessed, just recently nearly accessed, must be stored inside the cache memory. So for example, for I is equal to 0 and I is less than or equal to 100 and I plus plus, sum plus is equal to A of I. So here you can see the cache will store the block of address, the block of words, right? The address of the A naught, A of 0 and A of 1 and A of 2 up to A of 100. So it will store the block of address which is nearly going to be accessed. So since it is nearly going to be accessed, since the CPU require this data immediately, so this will make my execution of the instruction fast. So the next one is sequential locality. As I already told, it is a subset of the spatial locality. Generally, the program will often execute the instruction sequentially. So if you see after the execution of the instruction which is stored in the address x, the next instruction must be available at the address x plus 1. Therefore, the cache will prefetch the instruction address location in order to improve the performance of the pass. Okay, so this will comes under the sequential locality. So let us discuss about what is a definition for the cache memory. So if the active portion of the program and data are placed in the fast small memory, the average memory access time can be reduced, thus reducing the total execution time of the program. So such as fast small memory is referred to a cache round. Now we will discuss about the diagram of the cache memory, how it will be looking. So you can see I have a main memory which is of size 32K into 12, and it is connected to a processor. Generally it is CPU, and in between this one I have a cache memory which is of size 512 cross 12. So here you can see the 512 I can write it as 2 power 9 into 12. And the main memory, you can see the main memory it is 2 power 5 into 2 power 10 because k represent 2 power 10. So it is 15 bit of address and 12 bit of data. So you can see this 15 bit of address usually it is represent here in octal. Okay. So how to represent 15 bit in octal? So the minimum value of the 15 bit is 5 zeros because the O represent octal base that is radix 1 per. So the 0 I can represent in the binary as 000. Okay. And so I'm going to write 15 zeros. Okay. Base 2. So here I am going to use only the octal number as my address. So similarly, the maximum value is 5 sevens. Okay, the 5 7 uh, and you require 15 ones. Okay, so 15 one is a maximum value which is represented in the binary. So generally, the performance of the cache memory is frequently measured in terms of the quantity, which is called as hit ratio. So whenever the CPU finds a word in a cache, it is set to produce a hit. Okay. If the CPU requires some data, the data is present inside the cache, then it is set to be a hit. If it is not, that means then it is called as miss. Okay. So what is a hit ratio? Hit ratio is defined as a ratio of number of hits divided by hits plus Ss. So if the hit ratio is high, which means the CPU can access the cache instead of the main number. So this will make my processor to work fast. Generally, the transformation of the data from the main memory to the cache memory is known as a mapping process. So there are three types of mapping procedure is there. And the first type is associative mapping, set associative mapping procedure, then direct map. So first let us discuss about the associative mapping procedure. So it is more flexible and it is fastest. Why? Because this associative mapping will store both addresses and the data of the memory word inside this cache. Okay. So for example, of the CPU address which is 15-bit value which is stored in the augmented registers. Okay. Then you can see the pink represent uh, addresses and data. So this associative mapping will store both the addresses and the data. Okay. And here the associative memory is searched for the matching address. So if the address is found, the corresponding 12-bit data, which is read and it is sent to a CPU. So if no matches occurs, then the CPU is going to access the main memory. Yeah. So since the address data pair is then it is transferred to the associative cache dump. Suppose if the cache memory is full, okay, and this newly address and data pair must be displaced to make a room for a pair that is needed, which is not present in the cache. So the decision as to what pair is replaced, which is determined by the replace algorithm. Okay, that the designer will choose for the cache. So the simple procedure to replace the cell of the cache is a round robin order. whenever a new word is requested from the main memory. So this will constitute first in, first out replacement policy.